Fine. I think so now it's visible. There is no problem in it. So check everyone. This is what I explained actually. So here, so we need to find the nth term in the Fibonacci series, guys. Okay. So we are going to get so by adding previous two terms. Okay. So check everyone. So for getting so second term result, we need to add so the first and zero terms result. Okay. And for getting so the third term result, okay, f of 3 result, we need to add so the function called 2 and function called 1 result here, okay. And next, so for getting so the fourth term result, so we need to add so third term and next of all so the second term result, okay. So this is what given and so observe these constraints so carefully, everyone, okay. N value lies in between so 0 to 30 here, okay. And next of all, in topics, you can check that it is from so the recursion, and afterwards we can optimize this one in the memorize dynamic programming, so memorization or else so the tabulation method. Okay, so fine. And after completion of this, we are going to observe the similar question. So that is called the climbing states. Okay, remaining questions you have to go through, guys. So that is your task. And now, so fine. What we discussed here. Observe. So for getting nth term, so in the Fibonacci series, simply we should add f of n minus 1 and f of n minus 2. Okay. So there is the expression. So with the help of this, let us finish the solution. Okay. So have a look already. So class is given, and next of all, inside that Fibonacci method is given. Okay. N variable value pass it to this method, and we need to return integer value from this method. Okay. Self holds the address of the object, guys. Okay. So means with it, the class methods we call with the help of object and dot operators, right? Okay. So here, if you want to call this, okay, again we need to use the so self address. Within that we have so the object address, guys. Okay. So observe now how I am taking so the calling functions here. Okay. Return self dot Fibonacci of so n minus 1 and next of all so self dot Fibonacci of n minus 2. So don't worry about so this one self and all this, okay? You are going to study later in Goop's concepts, okay? So just now focus on these recursive function calls, okay? That's it. So I'll explain for the small values so that easily you can understood, okay? Like this only you should go for explaining in front of interviewer also, okay? Actually this one, so you need to prepare. So for explaining behalf of so dynamic programming so solution, okay. Sometimes this one is asked in interviews. So for based on loops or else on recursion or else on dynamic programming, okay. So let us take so n variable value as 2, okay. So for this value simply you can understood n variable value. So let us take 2. What happens here? So two recursive function calls generates, right? Okay. So one is Fibonacci of 1. So another one is Fibonacci of 0. Okay. Now, uh, whenever so function calls generates with these values, okay, that is with 1 and 0, we need to stop recursion here. Generally, so we stop recursion at one value, okay. So, but for this program, we need to stop recursion at so these two values here, okay, because two recursive function calls are so generating here, okay. So that is we need to stop at so the 1 and 0 here. Okay, now let us take so the base condition here. So that is if whenever n variable value becomes so the 1 or else so the 0, we need to stop the recursion, right? So the same condition I am taking here, that is n double is equals to 1. So or n double is equals to 0. In both these two scenarios, we should stop recursion. Okay. So if for suppose what we need to return to this function call one, so one, right, and what we should return to this function call here. So that is f of 0. It's 0. Right. So whenever function calls generates with 1 and 0, we need to stop recursion. Okay. So here, if function call generates with 1, we need to return so the 1 here. Okay. If function call generates with 0, okay, we need to return so the 0. So two values we need to return here. Okay, not just one. So where these two values we are getting, guys, okay, in n variable, right? So if n variable value so is 1, okay, we need to return so the 1. On returning n, it is going to return 1. Okay, if n variable value is 0, so we are returning n, right? It is going to return 0. Okay, observe everyone, return n. So for one value, this condition becomes true and it returns 1 to f of 1 function call. And for 0 value, this condition becomes true. It is going to return 0 to the f of 0 function call. So 1 plus 0, so we are going to get 1. That result returns to the main, okay, and stops the execution. It is simple. So recursion program. So for Fibonacci series, printing nth term in Fibonacci series, okay. Let us run and check. Yeah. So base case is accepted. Let us check hidden test case by submitting. Yeah, fine. So all 31 test cases so passed here, so you can check. Okay. Now fine. Now the thing is, next in upcoming programs you are going to observe. Okay. Like this, it is not going to be executed. Okay. Some hidden test cases are going to be failed. Okay. So based on the constraints, initially I said right. Okay. So here constraints you can observe n value lies in between 0 to 30. Okay. That's why hidden test cases are also getting passed. Okay. So we are not observing so that much big value here. So for suppose, so for big values, okay, uh, whatever the time limit fixed to our program so may exceeds, okay, in that scenario, how to optimize, I'll explain in this program itself, okay. So the same thing you are going to observe in the next program. And so before to this, I'll explain how this one is working in the backend, okay. So all of you check it once. It is very much so important and required. So let us take function call so 4, okay. So for function call 4, so first what's happening, guys, okay. Remember only this function call, so f of 3 is going to be generated afterwards. So next again control reaches to here, some f of 2 function call is going to be generated, okay. Only we are going to focus on so the left side function calls here first of all. Observe everyone. So for f of 4, so f of 3 function call is going to be generated. And next, so for f of 3, once again, if condition fails, okay. So f of 2 function call is going to be generated. Next, for f of 2, again, so if condition fails and it is going to generate f of 1 function call, okay. Whenever it generates with f of 1, so what happens if condition becomes true, right? It is going to return 1, okay. Once after returning 1, it goes for checking whether any function calls are left over, if any other part is left over for f of 2 function call. Yes, only one function call it generated, right? Okay. One function call it generated, right? So one more function call is remaining, right? That is called f of 0. Okay. Now what happens? F of 0 function call generates here. Once again, base condition becomes true. It is going to return 0. Okay. Once after returning so the 0, what is happening here? In place of f of 2 function call, only f of 1 and f of 0 is substituting, right? Okay. F of 1 plus f of 0 is substituting. So these two values gets added and next of all substituted in place of f of 2 function call, right? Okay. Next, afterwards, again it backtracks, okay, and goes for checking whether any part remaining left over. So for f of 3 function call here, as it just generated one function call here, so one more function call is remaining, so that is f of 1, okay. Once again, for f of 1, base condition becomes true, okay. So here, in place of f of 3, so this is going to be generated, f of 2 and f of 1, right? Already for f of 2, we got result 1. Now for f of 1, we got result 1. These two values gets added and replaced, substituted in place of f of 3. That is 2. Okay. Next, it backtracks, okay, and moves to the f of 4 function call. So here, this one also generated only one function call. One more function call part is remaining here. So that is called f of 2, okay. Uh, so after generating, so this f of 2 function call, so first it focuses on the left side function call, guys, okay. That is, observe how I am evaluating, how I am drawing recursion tree here, okay. So again for f of 1, what happens? Base condition becomes true. So in place of f of 1, 1 is going to be substituted. Okay, again it backtracks and checks whether any part remaining. So the leftover, so for f of 2 here, as it is going to generate one more function call, that is called f of 0. Okay, and for f of 0, it returns 0, and 1 plus 0, we are going to get 1 in place of f of 2. Okay. So earlier we got f of 3 function call result, that is 2. Now, so f of 2 function call result, we got 1. So these, in place of f of 4, f of 3 and f of 2 get substituted, right? F of 3 result, we got 2 from the bottom, and f of 2 result, we got 1 from the bottom. These two values gets added, and finally it returns the result 3. Okay. This is the so f of 4 result, okay. Already you observed here, okay. F of 3, see, f of 4 function called result is 3, right? Okay. Same result you can observe here. It's returning. So now, why we taken so this recursion tree here, okay? Why it's important, I'll explain now. So all of you have a look at so this. How many times f of 0 function calls are generating? 2 times, right? Okay. So how many times f of 1 function calls are generating? So it's 3 times, okay? Next, so check how many times f of 2 function call is generating here. 2 times, right? So you know one thing, when compared to the iterative approach, okay, recursive approach works slower because memory has to be allocated for these function calls, okay. So it takes some time in the backend, okay. So already it's working slower when compared to the iterative approach. But if you observe this program now, so for the same inputs, it is again and again generating so the function calls, okay. So means it becomes very slower now, okay. Actually, our program, so currently our program is working very slower, okay. So now we need to optimize it, okay. So for making optimization, so we have dynamic programming, okay. In each and every scenario, we should not move to the dynamic programming, guys, okay. So whenever we found the recursive function calls involves, okay, whenever you found so recursive function calls are generating with same inputs, okay, then only we should move to the DP, because in DP we are going to use the extra array. You are going to observe, means space complexity is going to be incremented, okay. So we need to keep that point also in our mind. So if recursive function calls are not generating for same inputs, then we should prefer recursion only. If recursive function calls are generating for same inputs, then we should go for DP. Although it takes space complexity, our major constraint is time complexity, right? Okay, that's why we prefer so that one. So fine, I hope you understood. So actually in dynamic programming, so we have two methods. Okay, one is memorization, that is recursive function calls, and uh, this one 2D array, array in combination. So another one is direct tabulation method, means without so recursive approach, iterative approach, and so extra array, dynamic array in combination, or else recursive approach in dynamic array combination. You are going to observe memorization. iterative approach and so dynamic array combination, you are going to observe so as tabulation method. Okay, so we have two methods here. Okay, but tabulation method only we are going to prefer. Okay, so actually each and every program after completion of designing, so in recursion here, so we move on to the next of all memorization. Afterwards we end up with the tabulation method, so like that. Okay, but so this takes very long time. Okay, so that's why after completion of so Fibonacci series directly, so I'll go with the tabulation method. So this program Fibonacci series I'll explain. Okay, so the memorization method also, but I'm talking about upcoming programs here. Okay, directly I'll go for explaining a tabulation method. Okay, and so before going to start dynamic programming, I'll display some theory information. So regarding so this, okay, all of you gone through that. Afterwards, let us start so discussing this. Okay, observe. So here, observe the first point, everyone. That is, what is dynamic programming means? Dynamic programming is mainly an optimization over plain recursion, guys. Okay, we are going to optimize the recursion with the help of dynamic programming. So you are going to observe that. Next, so what I said, when we should apply so dynamic programming. So read the second point, everyone. Wherever we see a recursive solution that has repeated calls for same inputs, we can optimize it using dynamic programming. Same thing I said. Same thing I showed you proof also with recursion. I hope you understood why I taken so the recursion tree also. Next, so how we can apply so the dynamic programming. So means so you can read the third point now. Okay, the idea is to simply store the results of sub problems so that we do not have to recompute them whenever so needed later. So simply we are going to store the intermediate results in the dynamic array so that again and again it's not required to calculate. So the same thing you observed in the recursion, right? We are going to avoid in the dynamic programming. So how you are going to observe? So next, what is so going to be happen? So what is the use of dynamic programming means? You can read the fourth point here. The simple optimization reduces time complexities from exponential to polynomial. Just now you observed Fibonacci series, right? Okay. So actually for that one it takes 2 power time complexity. Okay, so 2 power n minus 1, whatever it may be. So it is going to take exponential. So that one we are going to reduce to the linear. Okay. So you are going to observe now. And so generally, we take these programs. So Fibonacci series factorial program. So for explaining, so the dynamic programming approach. Okay. So here I'm preferring, so this one Fibonacci series. Okay. This interview program also. And now observe next these 2 points. Okay. How many ways we can apply dynamic programming means. So one is tabulation method. Okay, so another one is the memorization. Okay, so this one we call it as top-down approach, guys. Okay, because we start generating function calls from the top just now. You observe recursion, right? Likewise, so we are going to generate the function calls. Okay, we are going to generate the function calls and fill the table values. Next. So this one tabulation method so comes under so bottom up. Here we'll start filling values from the so zeroth index. Okay, in the array. That's why we call this one as bottom up. And here of while generating function calls from the top, we are going to fill the values. You are going to observe that. Okay. So here before to start memorization. Okay, I have to explain so the one more point. Okay. So read this table, everyone. So read the first point actually. So why we prefer so the recursion? Okay. So then afterwards we move on to designing so the dynamic programming here. Directly if we go for so designing so the dynamic programming solution, so you feel very difficult, okay? So once after completion of so the recursion or else so the memorization, so easily you can build the tabulation solution, okay? So read the first point. So everyone, state transition relation is difficult to think, okay? So in the tabulation method. So, but in memorization, you can observe state relation, transition relation is easy to think. Okay. So here, read the second point also, guys. Code gets complicated when lot of conditions are required. Okay, but here code is easier and less complicated. Yes, I understood that. So you feel that recursion is difficult. Okay, when compared to the iterative approach, but here, so even recursion itself you feel so better so easy when compared to this tabulation method, okay, so we can easily generate the formulas so sequences just now you observe for Fibonacci series, okay, afterwards easily we can make conversion into the tabulation because why it's required to finally convert into the tabulation means, okay, so here, although we are going to avoid generating so the same recursive function calls, but it is going to take some stack space. Okay, all it takes, right? It works some slower only when compared to the tabulation method. So memorization programs work slower. So you can observe that third point here. Okay, that's why actually it's very easy to think. So state transition and all these, right? We are going to done with either recursion or memorization, but finally we are going to convert in tabulation because it's required to make our program run faster. Okay, so this is what you are going to observe. Okay, so in this dynamic programming, so solutions. Okay, so now I'll explain how we are going to finish designing memorization solution. Okay, so all of you listen at once, or else I'll take just 2 minutes. Wait, everyone. So fine. So we taken function call so for, right? So here what I said in dynamic programming. So the very first step is okay, taking one so extra array, guys. Okay, 1 minute. See, we need to return so the fourth term, right? Okay, so means we need to fill so values up to the fourth term here. Okay, so zero, first, second, third, and so the fourth. Zero, one, two, three, four. Totally, if you count, okay. So we need to take so the array size with so array size as 5. Okay, same thing you are going to observe so in all dynamic programming solutions, okay, so initially we should create an extra array with so size plus 1, okay, remember this with the size plus 1, So we need to create an extra array. So actually, initially, so we can fill any values here, but I'm going to fill so none values here. Okay. Initially, so I'm going to fill all memory location values with the none. Okay. Next. So here to the recursive function calls, okay, so to some position, to some array position, we are going to generate so the recursive function calls, okay. So let us consider this is array A, okay, to A of 4 for position. So we are going to generate so the function calls, okay, two obviously two function calls only. So, but first of all, this function call is going to be generated, so that is f of 3, okay. So again for so third memory location, so we are going to assign two function calls. Okay. So first of all, this function call is going to be generated. That is f of 2. So again, what happens? Again, still we didn't reach to the base values, right? Okay. We are going to generate recursive function call to the second position. Okay. So means again only one function call initially generates, that is f of 1. Okay. Whenever so function call generates with f of 1, so we are going to fill the values. Okay. So we are going to fill value, so f of 1 with 1. F of 1 we are going to fill with 1. Listen my words carefully, okay? So first memory location, so we are going to fill with so 1. Afterwards, so again, same thing, it backtracks, okay? And checks, so any function calls so left over for this one, okay? Yes, one more function call is remaining, so that is f of 0, okay? Now for f of 0, whenever we reach it to the 0, 0th memory location, so we are going to fill with 0, guys, okay? Sorry, 0. Got it. And so now what I said, for f of 2 memory location, so only for f of 2 memory location only, we generated f of 1 plus f of 0 function calls, right? So whenever function calls generated, these memory locations gets filled with the base values, okay? Now, so whatever the once after executing so these f of 1 and f of 0, okay, so these values we are going to return to this function calls, okay. These two values addition result is going to be stored in the f of 2 memory location, okay. F of 2 memory location is going to be filled with 1. So I hope you understood. So here it is going to memorize. So once after generating, once after completion of so filling the values, okay, we are not going to generate so the function calls again. We are going to memorize, okay, which memory locations we already filled here, okay. Likewise, we are going to avoid generating so the recursive function calls for the same inputs, okay. Next, let us backtrack, okay. Only one function call so generated here. To the f of 3 memory location, only one memory function call generated. To that function call already one value returned, okay. So now one more function call is going to be generated. So that is f of 1, but this time it is not going to calculate so this because already, 1 minute, because already so the first memory location got filled here, okay, that is with 1. So it is going to fill with 1. Now 1 plus 1, what is going to be happened? F of 3 memory location is going to be filled with so none, okay. F of 3 memory location is going to be filled with none, and so again it backtracks, okay, backtracks and checks. So any function calls are left over for this, as one more function call is remaining, so f of 2, but again for f of 2 it is going to check whether it is already filled or not. Yes, it is already filled, okay. So with what value it's filled? With value 1. Directly it is going to return so that filled value now. Once again, it is not going to generate the function calls, okay. So now for 2 plus 1, so it is going to return so the result 3. Now if you observe now, so it is not making any calculation for f of 2 and f of 1 because already these filled here, f of so 1 and 2. So observe how the function calls are avoiding here. Only so 0 calculated one time, so 1 calculated one time, so 2 one time, 3 one time, and so 4 also one time. That's it. Okay. In this way, So it is going to avoid, so finally f of 3 memory location is going to be filled so with value 3, that 3 is going to be returned to the so main. Okay. So as I hope so you understood, so how we are going to work on it. Okay. Next. So afterwards, I'll tell you so how to convert into the so tabulation method. Directly, I'll show you so the recursive solution. So converting into the tabulation. Okay, so that you feel easy. But just for this program, I'll explain. So how a memorization method will be. Okay. So fine. Let us complete so the program now. Okay. So fine. So here we require one more extra function call, guys, because so we need to work with the updated array each and every time. Okay, so it's not possible to pass updated array to this function call because only one variable we can pass. That's it. N variable. That's it. We cannot pass so array here. That's why after taking some array, I am going to take another function call. What I said initially, we need to take so all memory locations. Okay, we should create an array, extra array with size plus one. Okay, n plus one. Remember this. This is the first step. Next. So in next two programs, I'm going to fill the values with zeros. Okay, there is no problem in it. But here, so zero is also one of the value, right? That's why I taken so the none. Next. Now I'm calling so the function here. To this calling function, I'm going to get the result. That result I'm going to return to the main. Okay. Now observe everyone. So self dot. So function of. Okay. So I'm passing array and next of all so the n. Okay. Now let us go for defining so this method. Define function f and so self next of all so array and so the n. Okay. So here what we discussed, if whenever n value on reaching to the 1 or else n value on reaching to the 0, okay, so we returned n, right? Okay, so simply observe wherever so you taken so return in place of that. So what I said, we need to fill so those initial 0 and first memory location values, we need to fill with so those values, right? In place of return, what I'm taking here, observe everyone, array of n is equals to n. Okay, simply. So array of 1 and array of 0 memory locations are going to be filled with the 0 1. So initially we are not going to get so 1 and 0, right? Okay. So observe this. Let us take so input 2 only once again. So now yeah, control comes to the else block, right? Okay, what I said. So to the second memory location, okay, so that is to the array of 2. So array of n, initially it takes 2 here, okay, array of 2. To this, actually, what is the thing you observed in the recursion? Okay, observe this. So self dot f of n minus 1 plus self dot f of n minus 2. Okay, what we discussed with recursive solution, easily it's possible to construct memorization. So or else so tabulation method, right? Okay, and what I said, in place of return keyword, we need to take so the array of n. Okay, remember this. Next, remove, see, in place of these function calls, okay, apart from at that by the time of reducing so the values, so we need to pass the updated array here. Okay, so extra thing so I'm doing here is so I'm passing some extra array. Okay, what's happening here, so two function calls are generating so with 1 and next of all so the 0. Okay, what happens whenever so this becomes so true, this locations, okay, array of 1 fills with 1, array of 0 gets filled with 0. Okay, and so for 1 and 0 values, else block won't works. Okay. After filling so the array of one value, remember this. So to this f of 1, to this memory location, to this function call, we need to return 1. So to this f of 0, we should return so this filled value, array of 0. That's why outside of if else, remember this one. So I am returning so the array of n, whatever the value it got filled. Okay, I hope you understood. So array of 1 filled with 1, array of 0 filled with 0, right? So array of 1 value we need to return, array of 0, so that is 0 value we need to return to here. Okay, so to here it is going to return up to the previously generated recursive function call, so the values are going to return. Okay, 1 plus 0, finally it becomes so the 1, and so the that result 1 is also going to be returned from the same return statement. Okay, but for the previous function call, for actually for function call 2, it checked this one failed, and so for array of 2 this one generated, but this one not executed for array of 2, right? Okay, now, so for array of 2, it is going to be returned. Array of 2, one value is going to be returned to here, and so the same value is going to be returned to the main. Okay, so this is okay, fine, clear. So one extra point we need to induce. Okay, so you observed in the explanation, right? So we taken some big value that is called 4. Okay. For that, what happened? First of all, function call generated for array of 4. Next of all, for array of 3 and array of 2, all these, right? So again, right side we got so the array of 2, right? One more array of 2 function call, array of 1 function call, so the generated. At that time, what I said, it's not possible to, it is not required to calculate, generate the function calls again. So directly we need to return values to the here, okay, to those recursive function calls. That is what you are going to observe now. Okay, if for suppose already some particular memory location got filled, so what I showed you, array of 1, array of 2 already if it is filled, directly return. So whatever the value filled in that memory location. So same thing, so I am explaining now. This is very important, okay? So observe. This one we already observed, just return statement we are removing and we are passing updated array. That's it. And extra return array of n you are observing. One more extra point you need to observe. If array of n, if it is not pointing to none, if it is already filled, so for suppose again if we got function call for 2, if it is not filled already we got so the result 1. The same result we are going to return. Okay. So return array of n. Okay. Again and again, so we are not going to make calculation, so we are going to avoid. So repetition of function calls. So this is the memorization method. Okay. So fine, let us check. So how it works. So base case is executed. Let us submit. Yeah, fine. So it's working. This is so memorization so method, guys. Okay. So just gone through for 1 or 2 minutes. Okay. If you have so any doubts, you can ask. So fine. I hope so. Each and everyone understood. So this one. So now let us move on to the recursive solution. Tabulation method, guys. Okay. So I said, although we avoided generating, so the recursive function calls for same inputs, okay? Still, recursive function calls are generating, right? Okay, it takes some time. So by with iterative approach, so I told you is it works faster, but directly it's not possible to design it, okay? So we need to move in this path only. So we should follow it. Okay, let us take that program. So first, directly I'll show you. So how to convert recursive solution into the tabulation method because we are going to follow this method only. So observe everyone. This is the recursive solution. So we observed in the beginning, right? Okay. So return n. Next, else return self dot Fibonacci of n minus 1 plus self dot Fibonacci of n minus 2. Okay. Now what is the very first step? After completion of recursive solution like this, actually, we are going to take some extra function from next program onwards. But for this program, I'll complete in this method itself. Okay. So the very first step you are going to observe here is taking some extra array here. Okay. So initially, I'm taking zero values now. There is no problem in it. So I'm taking n plus one size. Okay. Here next. Now, I'm running the loop, okay, from n number of times we are going to repeat, okay. So the loop, and I hope she understood, okay, n plus 1. So we need to print a value. We need to fill values up to the nth term, okay. Don't forget this. So this is the second step, okay, taking the loop. Next of all, taking the entire program inside the loop. This is the third step we need to perform, okay. Afterwards, wherever you observed n variable, you need to change it as I here. Okay, remember it. Wherever you observed n variable, you need to change it as I. And in place of return, already I said you need to take the array here. Next in place of n I. So next. Here also same guys. So in place of return keyword, we need to take the but in memorization we taken the n because in n variable only we generated the all values. Okay, but here in I variable we are going to get all values here. So next, what I am saying here is remove the function call. Okay, and in place of n take I. Okay, next remove the function call in place of function take. So array and next of all in place of n take I. Okay, observe how I am making conversion here. So finally after completion of the loop, we need to return the nth term. Remember, so in all most of the programs, in every program we are going to return the result what are present at the nth term here. Okay, so there is a simple way of converting into the DP. And now here you can observe values are getting filled at from the bottom. So first of all, 0 and first location values gets filled. Next of all, second memory, like a second index value is going to be filled with first and 0 index values. Okay. So like this, it is going to fill from the bottom. Okay. Let us run and check now. Yes, tabulation method. Table means simply 2D array, you are going to observe the exact table, okay? Here, so for 1D array, you can observe this table here, okay? Only one row table you can observe for 1D row, 1D array. For 2D arrays, you are going to observe both rows and columns, okay? Exactly, you are going to observe table. So fine. This is the tabulation method, okay? So for the Fibonacci series, check everyone. So fine, I'll complete so one more program so relevant to this one. Okay. So have a look at this. That is climbing states. Okay. This one asked in coding section also. Um, we may not expect some particulars of the program, so we may get anything. So we should go through. So whatever the program so asked in the so different tries all this. Okay. So this is the application program of Fibnox series. Okay. So check everywhere. You are climbing a staircase. Okay. It takes n steps to reach the top. Okay. Each time either so you can either climb one or two steps. Okay. In how many distinct ways can you climb to the top? Okay. Only one or two steps are allowed. Okay. At a time. So based on this, we need to find out how many ways we can climb to the so topmost. Okay. Topmost step. So here detailed explanation is given. Okay. You can go through later. So for if for suppose two steps are there, okay, we can move like this. One step and so plus one step. Or else directly you can jump to the second step. Two ways were there, right? Okay. Next, for suppose if n value is 3, so you can move like this. One first step, second step, and third step. Or else after moving to the first step, directly you can jump to the third step. Or else after jumping to the second step, you can move to the third step. Okay. And now observe so the constraints here carefully. N value lies in between. So the 1 to 45. Okay. So check this is also from dynamic programming, guys. Okay. So fine. And what is the hint here it's given? To reach the nth step, what could have been your previous steps? Okay. So we need to check it. And based on this, we have a min cost climbing states. Okay. You should go through this. Nth tribo, maxi number, min cost climbing states. Okay. All this you have to go through. So I'll explain now. Okay. So observe everyone. So we can finish this one very quickly, guys. Okay, don't worry. So let us take, we have only, so one step, okay? Only we have, so one step, sorry. So how many ways are there? Only one way is there, right? Next, for suppose two steps are there, okay? How many ways are there? So 1 plus 1, and so directly I'm moving to the second step, okay? So two ways are there, right? Next, let us take so three steps. How many ways are there? Just now you observed, okay? 1 plus 1 plus 1, it's one way. 1 plus 2 is another way. 2 plus 1 is the next way, okay? Totally we have so the three ways, okay? Next. Let us take so four steps. Okay, last one. With the help of this, you are going to understood one thing. Okay, what are the ways? One plus one is one way, or else one plus two, or else one plus two plus one. So or else two plus one, two plus two. Totally, you can check. So we have five ways here. Okay, next. So if you move further, okay. So last one. So check everything. Five steps. It's not required to calculate, okay? Because you can check the so results here, okay? So first we got result one. Next of all, so we got result two, okay? So if you carefully observe, so for three steps we got result three. So this result, so we can get so by adding so the previous two results, right? Okay, that is one and two. Next. So this result we are going to get so by adding previous two results, right? That is 2 and 3, 2 plus 3, 5. Next, likewise, directly, so I am going to write so the next result here, okay, that is 3 and 5. By adding so these two results, what we are going to get, that is 8 ways, guys, okay. I hope so you understood. This is in the Fibonacci series form, okay. So here we need to find so the values here, okay? Which Fibonacci series value we need to print for particular input, okay? Here input is giving in the form of a number of steps, right? Okay, and for some particular step count, okay, what Fibonacci series value we need to return here? We need to import. It's important. So here, gone through this, everyone. So one, first of all, for one step we got result one, and for two steps we got result two. Okay, so that is initially we are getting so the f of two result. Okay, next of all we are getting so the f of three result. Okay, so observe everyone. So I'm writing so the Fibonacci series values here. So that is f of two. This is f of three result. Okay, and this is f of four result. You observed in the tree picture also. This is f of five. Okay, and so this is f of six. See here you can understood one thing. So based on this. For one step, we should print f of 2 result. For two steps, we should print f of 3 result. For three steps, we should print f of 4 result. Okay. Next of all, for four steps, we should print f of 5 result. Okay. Next, so for five steps, we should print f of 6 result. Okay. Based on this, we can make one confirmation so that number of ways to reach. Oh, 1 minute. Number of ways to reach nth state so is simply equivalent to Fibonacci of n plus 1 value we need to return. For getting so the result of nth state, number of ways to reach nth state, simply we need to return so the Fibonacci of n plus 1. Just now we completed so the Fibonacci series value program. So what we need, we got some say nth term, right, to the Fibonacci function, we return the result. Now, so we are going to have number of ways to reach nth state function, okay? So from that function, what we need to call? So we need to make one call, so like this, Fibonacci of n plus 1, okay? So that for that particular value, it is going to return some result. Fibonacci series program is going to return some result. That return the same result we are going to return back, okay? So to the main. So now let us complete so the solution of this one. Okay. So have a look. Yeah, fine. Directly I'll complete so the tabulation solution now. What is given? Climb states method is given. N variable value is given. For reaching nth state, what I said, we need to return so Fibonacci of n plus 1 value, right? So to the Fibonacci function, now I'm passing so the n plus 1 value here that is going to be calculated in the method and result is going to return. The same result we are going to return back, okay, to the main. Let us define so this function now, okay, so define so Fibonacci self and next of all n plus 1 value I am getting copied into the so n variable here next. If so for suppose let us take directly tabulation method now, okay, or else I'll show you a recursive solution. So check whether it works or not. Afterwards, you can understood what is the need of tabulation method. All this we're clearly with the help of this program. Okay, so fine. So what is the program you observe? N double is equals to 0 or n double is equals to 1. So we need to return 1. Okay. So if not, what we take in return self dot Fibonacci of n minus 1 plus self dot Fibonacci of n minus 2. Okay. This is what you observed, recursion program, right? Now let us check whether this one works or not, recursion. Observe. Yeah, base case is executed. Let us submit now. So check how much time it's taking here, okay? Here itself we can understood that so we are going to get some TLE error, okay, time limit exceeded. See, out of 45 test cases, okay, only 21 test cases passed here, okay. What is the last executed input here? You can check. So that is 44. Imagine, so you observed for fourth term, right? Okay. So the Fibonacci tree or else a recursion tree. Imagine for 44 value, how many so recursive function calls are going to be generated, and for how many values, same values, recursive function calls are going to be generated. So that's why we need to convert back into the tabulation method. So now let us complete it. Let us take so F array. Initially, I am taking some n plus one size array. Next of all, I am running so the loop for I in range of so n plus one. Okay. Next, I'm taking so the every entire thing inside so the loop. Okay. Again, I'm explaining. So the Fibonacci series, listen carefully now. Okay. So what I said in place of n variable, we should take so the I, right? Okay. And in place of return keyword, we need to take so f of I. Okay. So same thing I'm making so the change here in place of return, I'm taking f of I. Next, in place of function call, I'm taking Fibonacci array, and in place of n, I'm changing so I. Okay. In place of function call, I'm taking array. Place of n, I'm taking so I. That's it. Finally, after completion of so the loop, we need to return so the f of nth term. So let us check now whether it works or not. Okay. Yes, best case accepted. Next of all, so let us submit it. Okay. Only for the first program, it takes more time, guys. Okay, next upcoming programs easily can finish. Now check how much time it's taken. Okay, 0 milliseconds, it's finished here. It's beaten 100% of all solutions. Okay, I hope you understood. So why we discussed all this. Okay, we need to optimize the solution. Recursive solution for recursive solutions, we are going to get TL errors. Okay, so whenever you are going to get TL errors, we need to design so the program with DP understood. So this okay for some backtracking programs. So you are going to have small values, so constraints. Okay, in that case, it is going to be executed. So but for big values, so recursion programs so may get a TL error. In that scenario, you should prefer so the DP. Okay, remember all these approaches. So check it once. One more last program I'll explain in this session. That's it. That is based on strings. Okay. So just gone through this program at once. So fine. So now I'm going to explain. So very important. So interview program and important for so the coding section also. Okay. So I'll show you the proof. So how many times this one repeatedly asking so the different companies here. Okay. Afterwards, let us move on to the so understanding so that program. So that is longest common subsequence. Okay. Observe here. Longest common subsequence, so 30 plus companies. Okay, here it's given 39 plus companies. Okay, nearly some 40 plus companies. So this one asked. Okay, it's very very important, guys. It is present in all platforms. So here you can check in the lead code platform also. That is the longest common subsequence. So only one time, so I'll explain this. Okay, again, so in the college, regular hours, all this I'm not going to explain. So listen carefully now. Okay, so for string comparison based programs and for string edit programs, so that is insertion, deletion, and updation programs. So we are going to prefer so the DP here, okay. So before to that, I have to explain. So there's so many things, okay. Afterwards, let us move on to this problem statement, okay. So fine, observe. So first of all, we should know information about so this that is sub arrays, okay, and next of all, so the subsequences. Sub arrays means only contiguous. Contiguous means adjacent, guys, okay. Contiguous or adjacent memory location, so values, okay. So fine. Let us take so one array. So observe this. That is 1, 2, and so 3. So here, let us take so subarrays. So one is subarray. So single value itself is also called as subarray. Okay. Next, so 1, 2 is another subarray. Next, so because these two are in adjacent memory locations. Next, so 1, 2, 3 is next subarray, right? All these are present. Entire array itself is also called as one subarray because all these are present in contiguous memory locations, right? Next 2 is the next one. So 2, 3 is subarray and the 3. But you cannot, so you should not take 1 and 3 here, okay? So because 1 and 3 are not present in the so adjacent or contiguous memory locations, okay? So for suppose if we included so 1 3, so among along with these, okay, subarrays, then we consider so all these as subsequences, okay. Subsequences means both contiguous and non-contiguous memory locations so values, guys, okay. uh, So might be if cadence algorithm, all this completed in your so classroom sessions, you can already understood so the subarrays, okay? But so subsequences, I think so it's new. No one I think so explained programs based on this. That's why now first of all I'm giving you the introduction. So regarding this, afterwards let us move on to the programming, okay? So what I am saying here is okay. Observe everyone. So subsequences means both contiguous and non-contiguous memory location values. Okay. So let us take so the same array here now, that is 1 2 3. Okay, so 1 1 2 1 2 3. So 2 2 3. So 3. Apart from this, if we consider 1 3 means, then these are considered as subsequences, guys. Okay, so 1 minute. Uh, so why we discussed all this? Okay, so you should remember one thing. No, one more thing here. So 1 3 we can take. So but 3 1 we should not take. So order is important here. Okay, we should take it in the same order, guys. Remember this. Next. So now what is the program we are going to discuss? So the common subsequences, the longest common subsequence, right? Now let us focus on, so first of all, subsequences, next of all, common subsequences, finally, longest common subsequence. Let us take, so subsequences now. For some two arrays, two strings we need to take here. Okay. So if we have some two strings, then only we need to check the commons or subsequence, right? Then only we get this terminology. Might be so you have knowledge on this highest common factor or greatest common divisor. Okay. So we take some two numbers factors. In that we take some common factors. Afterwards we go for identifying so the longest or highest common factor. Okay, that's greatest common factor divisor. So likewise, so here I'm taking some two strings. One is ACD, another one is CED. Okay. What are the subsequences of this one? Let us take A, AC, ACD, C, CD, and so D. And next of all, EAD. These are the subsequences we have for ACD. Next, let us take so this C, CE, and CED. Next, E, ED, and so D, next of all, so CD. Okay, good. See, among these subsequences, we need to find so the common here. Okay, so what are the common subsequences? We can ignore this because these are starting with the A. So A letter is not there in this so string. Okay, this is string one, guys. Okay, this is string two. Okay, next. So you can check in this remaining. So C subsequence as it's present, C is present. CD it's present here. D it's present here again. So you can ignore this AD. So only three subsequences are common here. So C, D, and next of also CD. Among these, so what is the longest common subsequence? This one. This one, the length of this one is 2, right? Okay. We need to return that length 2 from our program. That is what you are going to observe. Longest common, so subsequence of this one is, so CD and the length of that one is 2. That length we need to return, okay? So how we can think about so the recursive solution here, how we can convert into the so dynamic programming. So all these I'll explain detail recursion tree, and finally I'll explain so the table also here. Okay, so how the table values are going to get so filled. Okay, so this is the very first program. So you are going to observe from the 2D array here. Okay, actually, so we need to work with the two strings, right? Okay, from here onwards, you are going to observe so 2D arrays. Okay, so all this you are going to understand later. So now, first of all, let us see the problem statement, and afterwards I'll explain how to think about so the recurrence. Okay, of this program. So have given two strings, text 1 and text 2, return the length of their longest common subsequence. Okay. If there is no common subsequence, return 0. That's it. Okay, fine. The same thing, so I explained. After by taking two strings, I taken first of all subsequences, next of all, I taken so common, next of all, finally, I told you that we need to return so the length of that longest common subsequence. Next. So here, subsequence information is given. A subsequence of a string is a new string generated from the original string with some characters deleted without changing the relative order of the remaining characters. Same thing I explained in the subsequence definition. Okay. Next, so here example is given. ACE is a subsequence of ABCD. One of the subsequence is given. Common subsequence information is also given here of two strings is a subsequence that is common to the both strings. Okay, and the same example is given here. Some 2 to 3 examples. So here no subsequence is common. We need to return 0, and it is from dynamic programming. So you can check. Uh, so here DP information, all these formulas were given. Okay, after this, your work is to go through the so similar questions of this one. Okay, so that it is useful, guys. Okay, next. So now I'll explain so how to design so the recurrence relation so for this one. Okay. So what is given here in the coding screen check everyone? Longest common subsequence method is given. Text1 string and text2 string is given. We need to return so the integer from this. Okay. So I'll explain step by step. So with that, I'll type so the program also here, okay? So that it becomes very easy for you to understood. Simultaneously, I'll finish so explanation and so the typing, okay? So fine. First of all, what are the steps we need to follow for designing so the recurrence relation? So for writing recurrence, let us see now. So steps to follow to write. So the recurrence here, okay? Sorry, ma. 1 minute. So just let us end up like this, okay? So fine. Mm, So the first step is so express problem in terms